see how to download the OpenSees software. So simply we need to enter the OpenSees word in the Google. Then we can see here the link for downloading the OpenSees software. Then go to the download option, and here you need to enter the registered email ID here and then submit. Then you can download the OpenSees software, as I already downloaded it on my computer. Also, in order to edit the file or modify at any time, you need to download the Cypress editor along with the OpenSees software. So here you can download it from this website here, Cypress editor. Through this you can edit the file at any time. The windows will be like this, and you need to download here. I already have the two files already in my computer. So after that we will see how we will work on the OpenSees. Simply here are the three things. Like first we will go to the OpenSees wiki, and here you need to go to the OpenSees user, because we are not the developers. And then go here for the getting started. You will get these options. Like first you will get the brief about the OpenSees, what is the OpenSees software, and then how we can how we can download the OpenSees. And then which we need is like model builder. Here if we need to model any structure or any member in the OpenSees, then we have and then analysis that structure or that member. We have the three things. First, we need to define the material properties for the member. We need to define the graphical representation in terms of the coordinates, like what is the origin, what is the endpoint, and where are the nodes located in the member. Then after that we need to give a analysis procedure to the OpenSees software. We will see how we can use those things later on in the next video. And after that we assign the analyze option to the OpenSees software, by which it completed the analysis process. In model building, we create the nodes, elements, and the material properties. And in analysis part we define the load, like whether it is the gravity load, whether it is the cyclic load, or the static push over, or cyclic lateral load, or the earthquake load, and some other parameters. Then in analyze part we define the like how and what are our objectives to perform the analysis, what we need in the analysis part. So first we need to see in model builder, either we are working in the 2D or whether we are working the 3D. Like if we are working to the 2D, then here we need to enter here the number of the dimensions ndm at 2, and the degree of freedom is 3. So this is the one required line which we need to enter in the OpenSees or in the Cypress editor. After that we need to assign the nodes, like what is the origin, like here what is the origin point and what are the node dimensions or the node coordinates of this point, and node 2, node 3 and the node 4. Here like node 1 is at 0 and 0. Here value of the x is 0 and value of the y is 0, because it is in the 2D, not in the 3D dimension. Then we need to assign the constraints, like either node 1 is fixed, or it is free, or hinging, or what is in our problem, or in the research problem. Yeah. So for that we need to give the command of the fix. Here 111 means it is fully fixed, and then we need to assign the elements if we are using in a problem like this area and the beam area. Simply we will see it later. And then we need to assign the material properties. For that we will go to the command manual. Here you can see the everything: modeling commands, analysis commands, and the database model element. Then here you can see the material parameters in this uniaxial material, whether uniaxial material or whatever we need. For the material we assign steel 0102 according to the properties of that steel, and what are the parameters which we need. If we use the steel 01, we have only these little parameters which we need to enter in the OpenSees file, and you will assign the material by these parameters, and these are the required parameters which we need to enter in the OpenSees file, or for the uniaxial steel 01 material. And here you can assign these A1, A2, A3 and A4, or these are the optional also, and these all are the depend on the material which we have, or which we tested already, or which we want to use in our experiment. And like if we use the hysteretic material, here we have it bilinear curve or the trilinear curve. We need to assign the coordinates of this graph, or this model of the hysteretic material, like pitching and the damage factors also. And similarly for the concrete material, if we have the concrete which has the 0 tensile strength, then we can use this concrete 01. And if we have another material which has the linear tension softening, we can use this concrete 02 material. And similarly, if we have the fiber reinforced polymer or some other materials, we can assign those to by these materials. And besides this, if we have another materials which are like elastic, elastoplastic, or something like bond slip, we can use another material from this for assigning that material. And then here this is also the same. Later we will see how we can assign those uh, when we go to the um, Cypress editor file, and here I only mentioned you what are the things which we need to assign in that file. After that we have the constraints commands and the number of command and the algorithm or the analysis command. And the analyze command, usually we need to assign these all things, or some may not. Analysis command, we need to whether we want to perform the static analysis or the transient and the variable transient. We need to uh, type the things like accordingly. And in analyze command, uh, we need to enter the incremental values and the minimum and the maximum steps here. So also what are the things which we need in the output file? We need to mention those things in the output command, like recorder. We need to whether we want the force parameter in the output file, or whether we want to the displacement or some other things. So in here we need to assign those things here accordingly. After that any other thing here are also the problems mentioned here, like examples here, like here if we are using the structural example, then we need to see here our basic examples. You can see those here because the already developers are already mentioned or uploaded the examples in this file, in this website. And we can also perform the we can also perform the moment curvature analysis to the section, like if we go to the reinforced concrete portal and we are analyzing the gravity analysis, then we can see here this is the these are the dimensions of the portal frame. And here first we need to put the or enter the model parameters, like we need to enter the node parameters, node 1, node 2, node 3 and node 5, and after that we need to assign the constraints of those nodes, whether those are the fixed or hinged or whatever those are in the actual condition. After that we need to assign the material property of the section or the members, like the concrete and whether the confined concrete or the unconfined concrete. After that we need to assign the steel parameters or the reinforcing material parameter by F1, Fy and the Young's modulus or the some other parameters. After that we need to assign the width and the depth of those members which use in the portal frame. And we can also enter here the cover used for the reinforcement. After that, the most important parameter is the fiber section, how we can assign the section, or how we can create the fiber section for the member. After that we need to assign the geometry, like linear or whatever it is, and the element type from 1 to 1, like this is here these are the 3 elements 1 to 3 is one element, and node 3 to node 4 is another element, and node 2 to 4 is another element. So we need to assign the properties here also. And after that we need to assign the load, whether it is the gravity load, whether it is the actual load applied on at any nodal place. After that, the analysis procedure was written here with some commands, and in the output file what we need to provide those things, and enter the records. So this was the overview regarding the OpenSees and the things which we need to enter, which we required for the analysis procedure of any member. So in next video we will see how we can actually create, or how we actually analyze anything or any member, whether it is column or beam or any port of RAM. So thank you for watching, and subscribe and share if you like the video. Thank you.